Testing audio. 1, 2, 3. Sounds good. So we can get started. Welcome back. This is the Discourager of Hesitancy. And we are building a game with no game engine. We're doing it all from scratch, minimal dependencies, only adding abstractions when we need them. So today's plan is to finally do saving replays. So get your beverage of choice ready, strap in, let's get rolling. Bring up our basic documentation. So here was the good news. Last couple of weeks, we were going through all those refactors, and it was kind of a pain in the keister. But when we bring up the game in release mode, we actually increased our release, our frames per second quite a lot. Last week, I think, was 2200. That's not right. 2000. 2100, 2000, 1600, 1700. So yeah, being back up around 2600 is excellent. Good. Oh, Dravest. Good afternoon. How was my weekend? It was good. It was good. I got all of the wood burning and tracing finally done for a job chore chart for my kids. I just got to build the thing to hold those. Ran some errands on Saturday, drove around town, got the oil changed, haircut, that sort of thing. Yeah, pretty good weekend. How was your weekend? How goes the web development? Just getting ready for the week here, warming up. Get started. Row 5. It's everything except what I want. There we go. Okay, so what we did last time was we were taking all of the user inputs of note and running them through a single function so that we can capture the events of note and record them for our playback. It was pretty good as well. Very nice and calm. Web dev is going good. Continuing tomorrow, working on it for the rest of the week. No meeting until next Monday. Yes. It's nice when there's no meetings and you can get some real work done. It's one of the reasons I quit my last job. It was just wall-to-wall meetings. It was a little bit silly. one of the reasons. Good. Good, good. So for tasks, we need to record user actions and game state. So let's go look at what we were doing in game scene. Add event. This is the key. Got those all tested. So we have an opcode, which can be an 1 byte value. We've got all these A's and B's, which can be 8-bit values. So I think what we're going to do is we're going to need a buffer to store events in. Bad jobs, Laura. There were more meetings than actual work, so to speak. Yep. Yeah. Yep. It's no fun. It takes all the joy out of programming. So one thing we need is a uint8t. Go int 8-bit integer. Let's see here, static const int replay buffer size. We'll just give ourselves a kilobyte of data. Replay buffer. Let's char star replay file name. Let's just go 1024 for now. Make it simple. What else do we need? We need an offset. Underscore replay buffer offset. Okay. We could have three. Let's just have a simple overload. Do we need an overload? Well, we don't need an overload. Let's go to not an overload. I mean a separate function. Void add to replay int 8t as a byte. That's basically it. So what we need is this thing. Okay. So we have a replay buffer offset, which is where we're going to start writing our data. We need to get a replay file name. The most similar snippet of code we can steal that from is in application. where we get our application directory, get our config file name, get our log file name, and our high scores are also going to need to know about this app directory. So I think we might move this into a global static class. Right now I have one called constants, I believe, which we can rename to like global. Hey Pat, what's up? We're just getting warmed up. We're just starting up. So that's what we're doing. Waking up from our weekend. We're gonna do saving replay data to a file. What are you up to? How's your weekend? Yeah, I think I might change constants to global. Much work to do here. We're gonna do this thing today. However, we have discovered that we need to refactor constants to global. Add after and file functions methods. I think that's going to be good. I am making a cheeseburger deep dish. Nice. Just got done porting a ROM to the SMWPC port. Cool. Super cool. Which ROM are you porting? They have support for ROM hacks, but their assembly implementation is wacky. Oh, the half manual. Yeah, that's always fun. Still, sounds like a good project. Always fun. All right, so do I even want this to be a global? Maybe I'll just namespace it. Rename file and buffer to global.hp. Go to the other global constants. Rename file and buffer. Global.c. I know we use this in global and in game scenes, so let's just do that real quick. Global speed. And then lastly, make file. There we go. Just click clean and debug. Build. I assume there are more things that I have to rename, but it's a good start. Kaizo Mario World. Cool. Send you the zip later so you can check it out and see the kind of stuff that I play. Nice. Okay. Yeah, sounds awesome. Global HPP does not need that. Let's put this all in the header. I have to declare it static. Let's see here. Namespace constant. Should it be static? It probably should be static, right? Namespace scope was deprecated. Okay. So yes, not necessary. Okay, then. Oh, doesn't need to be initialized in the header, I guess. All right. Okay. Oh, uniform RNG uses this. That makes sense since we sample a point and a circle. Fine uses it. So let's clean those up. Kaizo was the original Mario Maker with highly more skilled players. Okay. Most people had to hack ROMs with straight 65C816 assembly. Yeah. There were some fun little programming hacks I heard about from people that developed on those old hardwares. That's pretty cool. You had to pay attention to every single byte and how memory works. And sandbox. A friend of mine built an entire SNES game from scratch, and it's actually smart, insanely smart the things they did. Yeah, yeah, absolutely. They had such limited resources. They had to be very clever, and they had to know the spec inside and out. And the spec was small enough you could know it inside and out. There were definitely some not abuses, but some very non-manual use of some of those functions that are available in those architectures. Okay, constants don't seem to be a problem. Yeah, everything seems to be working. Perfect. Okay, so that's item 1 in the old journal. Okay, now application. We're just going to steal that into global. Let's see here. We need logging. We need these two things. And probably these things. Okay, global thinks application is a thing. Oh. Global can have access to it. And application cannot. Okay. Okay. So application has a few constants that we need. Nothing else cares about the application. So let me just grab these out. Nobody else cares about the version numbers. Make this as simple as possible. Name, window title. That kind of argues for app icon moving over there as well. As well as version. think that much getting pulled in makes sense. So global gets access to the image warehouse. Application. Get rid of that. Needs access to globals. Global. So there will be times in the future where we want maybe backwards compatibility, so we need to be able to check our version number from anywhere. So that's not unreasonable. What else did we do? App title. It's now coming from global. App icon is now coming from global. And let's just see how far we got. Of course. Remove some namespace in here. Okay, then application. What release build in application or in global? Probably in global. That's the kind of thing we might be able to check. Let's go release build. Okay. Global release build. Oops. Okay, global app name. Global app name. Global app name. Okay. This one. Okay, that's basically it. As far as that goes, now application. We're gonna make a small change here. Get. Let's see here. Global. Get app file name. Yes, and then this is basically something like this. Oh, but I was being clever. Look at how clever I was. Extension. You can break that out. That's fine. Extension. Ultimately, this is basically the same. Instead of log, it will be file name extension. Okay, fine. Result. 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 There we go. Okay, we're gonna pause right there for a quick restroom break. And we'll get right back to it. Okay. Now, application will no longer need these. Or this. That's my theory. Which will make other things fail, but we should have moved that functionality out. So global get app file name. Given this is a log file. What did I call those before? Was it just oh no. You went with global app name log. There we go. What was the config file name? Maybe I should double check that. What the extension was. CFG? Maybe? I'll just check real quick. Yeah, CFG. Application load config. All right. I don't like this here. I'm thinking I may break that out into global as well as a does file exist. Cool, does file exist? Turn is it greater than or equal to 0? So we can say if global does file exist. That just makes that a little bit more readable. In global, where we get the app file directory, we also use this. So if does file exist after, let me just switch the logic a little bit. Here, down, down. There. The file exists, we're done. Otherwise, we make a directory. Maker, I think, is already included. Therefore, application, in theory, no longer needs this or this at all. Maybe this one. See how that goes. Yeah. That is correct. Global HTTP. So global has stat once. And oh, that's it. So in theory, everything should just load up as before. Does. And my settings are the same as they were before. So it worked. Good. Uh-oh. What is this? Cannot subscribe to some things. It is saving the file in the right places. Could not find file. Still could not find file. What? So it says it saved it here, which is the same as the could not find. Oh, did I invert the logic? There we go. Okay, so check the config. If it does not exist, you cannot find it. So that should be all better. Okay. So position looks good. Something's going on in the settings. I don't know what. That all should have worked, so. Yep. Okay, everything's good there. So we've broken nothing there. Something in settings. Okay. Rename constants to global. Moved application user directory file name handling to from application to global. Yep. Okay, running away here. Global now handles application directory and boundaries. Okay. That means in game scene, we need to get the replay file name. So I have to decide a few things. Let's go back to our journal. On Friday, we started designing what we would need. Where did we put that? Oh, no, on Friday, Thursday. So yeah, Thursday, the 29th. We added better notes. Oh, replay design. There we go. So we need a start timestamp. We need a magic number. Magic number, starting timestamp. CRC hash, something to say this file has not been tampered with. Like the file names to be unique, which would probably be based on the timestamp. So let's see here. See system time. Get time of day. All right, well, let's get time. We do care about that. A magic number. So in application, we have a magic number that looks like this. So in game scene, we need something like this, which is going to be if we go to // users sudo app roaming, load up our config file. First thing we see is WSCF. We want something like that in our game scene. So replay magic number. If I remember right, let's see here. We have to reverse the character order. W is 57. Okay, so WS replay, RP, or playback, or save game. Replay, probably replay. So I need R, which is 52, and then P, which is 50 in hex. So word sleuth replay. So time. When we start a timer, let's see here. What is the name of the timer? This is a stopwatch technically. Okay, stopwatch pause. Enter letter. If it is not running, start it. And that is the timestamp we want to get on the first word. We want to know what time they started the game. Because that way, when they send in, they're like, oh, hey, I set this 3 days before the other guy did. We will know who has the actual world record by getting there first. Capture the timestamp. Hit replay file name. Reserve hash space. Let's see here. Capture. Magic number. Okay. So a couple of things our game scene needs. Oh, 1 byte. 2 bytes. 4 bytes. Replay buffer at replay buffer offset equals byte. Easy enough. Just make these value. We might not need this 2-byte version. We might just need 1 and 4. Let's not do it before we need it. We're just gonna type on it. Int 32t pointer of underscore replay buffer plus underscore replay buffer offset equals this value underscore replay buffer offset plus 4. That's basically it. So what we're doing is we're taking the pointer to the start of the buffer, adding an offset, casting that as an integer 32-bit instead of an 8, and assigning that pointer that value. Then we move our offset by 4. So that's nice and easy. Add to replay 4 bytes. I want the magic number. Game scene replay magic number. Okay. We have a couple of options. So we're not going to worry about it right now. We're just writing data into a buffer, which we have not written to disk. We'll not write to disk yet. Until our buffer is full or at the end of the game. So the timestamp is where we need to do the timey things. Timey. Actually need to do this. Okay. So time given a time structure actually gets the time from the system. Time info gets me probably a bunch of stuff like it's been a while since I've looked at this, so we're gonna have to get time of day. Interesting. So let's look at what a time t contains. And then a time info. What does that contain? Okay. All it does is contain a time t epoch. Although not defined by the C standard, this is almost always an integral value holding the number of seconds since 1970. So Working on holidays. I don't know. I never thought of Labor Day as much of a holiday, except that it was sometimes a day off. But I'm like, this is fun stuff, so I don't really need a day off. What's up? You're not afraid of UB. What's UB? Universal University of Buffalo. There we go. No, I'm not afraid of the University of Buffalo. University of Baltimore. Chrono time T. Yes, that's. C99 C++ yeah, so this will work fine. Yeah, if it was my job and I needed a break, I would definitely be off today. But actually, oh, and an announcement, I guess since everybody's here. Next week will be a short week. I am going camping sometime next week. I don't know if it's Wednesday, Thursday, Friday, or Thursday, Friday, Saturday. So I will keep you posted as I find out what the schedule is, but I will be camping next week. Also, another reason I'm not taking a vacation day today. Not afraid of UB. What is UB? UB acronym. Maybe this is a Sling internet thing. Yeah, not sure. You have to give me undefined behavior. Oh, I see. Undefined behavior. I'm not afraid of undefined behavior. I hate undefined behaviors. I wish people would just say the program exits or something like undefined behavior. I don't like mostly. Um, Afraid of. It is harder to debug undefined behaviors. Parts of C++ where the spec says compiler can do anything now. Yeah. No, I'm not a huge fan. What's up? I'm kind of curious. Have you ever had a problem with unaligned memory access or strict aliasing? Yeah, I've misaligned my memory all the time. That's happened before. In this case, it's not in a struct like the. Where we're doing this part. It is an array of bytes, so it should not worry about alignment at all. And then I'm going to write 4 bytes into the array. Oh, you mean this part? Okay. I have not run into a problem where writing to an unaligned location is a problem yet. Do I care enough to be more careful? I think until it's a problem, as long as this works, I'm not gonna. Yeah. I don't know. I've not had a problem with hacking binary byte arrays. So I don't. Unless this causes me issues, I think I'm just gonna roll with it. Oh yeah, this is not a high performance component. This is when a user does something noteworthy or interesting, which is a keystroke, a mouse press. This is not every frame. This only happens on user input. So what's the typical user input is 30 words per minute. It's really not that many keystrokes. So the performance, I'm not that worried about it. Yeah, SIMD would absolutely punish you, but for this case, I'm not worried about performance. We actually got a lot of performance back over the last 2 weeks of optimizations. We did a check on last week's end of game stats. We're back up to 2600 frames per second in release mode. So pretty good. Mem copy. Yeah, maybe mem copy would be safer. 4-byte mem copy is going to be basically optimized to what I'm doing. Mem copy. I'm using mem copy elsewhere, so I'm gonna have to replace it anyways when I get rid of libgc. Yeah, we can do mem copy. Let's do it. Let's do mem copy. Let's just do it. Mem copy's not hard. We've already got string imported. It's yeah. We can do that. I just have to remember the syntax. Mem copy. Destination source. Byte size and count. Right. Oh no, it's just bytes. Just bytes. Okay. Destination source and bytes. Then copy here the address of value and the size of value. Oops. There you go. No more undefined behavior, I guess. A spec legal way of going around strict aliasing. Yeah. Yeah, I usually don't think about it that much. If I tell you to write bytes here, I expect you to write bytes here. But yeah, probably safer to copy it. Okay, so where was I? I guess we were actually using this. Oops. Okay, so we got our time, which is a number of seconds, which we do want to add to the replay. Add to replay 4 bytes. We want the raw time dot epic. There we go. No, it's 0. Yeah. Okay. Capture the timestamp. We're gonna save ourselves some room for come on, there we go. Reserve for hash. Now we're using time info to get us a file name. I like to read the occasional blog post with tidbits like these. Yeah. There's just so many of them. Like, might be very valuable to have a compilation for ease of finding these kinds of tidbits. Get underscore, what's the current level or something? I don't know what I called it. Just level. It's 0 or 1. Ugh. There we go. Okay. I don't use C++ at work though. I'm probably just going to get worse. Yeah, I spent a number of years at work doing Python things. Then at another job, I did a bunch of like web development stuff. So a lot of Python, some JavaScript. Yeah, I was definitely, and I'm still trying to recover from some of those years of Rust. I've tried Rust. I wasn't a big fan. Probably already told the story, but if you want to hear it, I can tell it again. What my beef is with my brief foray into Rust. There were some things that I really liked. I'm not gonna lie, but ultimately it fell into the same trap a lot of languages do. I think. Yeah, so it should be 1. Okay, if our level is 1, blah blah blah. Which trap? Okay, so C protects you from absolutely nothing. You're perfectly allowed to shoot yourself in the foot all you want. Yes? Which means to use it well, you have to understand what it's doing. Then along came somebody and said, well, that's too hard for developers. Developers are morons, which, granted, statistically, at least half true. But then they said, let's make a language that you don't have to keep track of pointers. Null pointers are what cause problems. So we're going to make a language called Java. And you're not allowed to access the actual underlying pointer stuff. Everything exists on the heap. You have no control where it's allocated. You have no control when it's removed. We will reference count everything, and we will garbage collect when we feel like it. So it took away control from the developer to make idiot developers' lives easier. Okay? However, pointers, most of the time, aren't a huge problem. You learn to manage them, right? So Java just treats you like an imbecile. Or, and here's another one, operator overloading. Java won't let you do it. Why not? Why not? Why can't I? Or maybe this is old knowledge, but maybe Java's finally caught up. But like, if I make a vector library, I want to use the addition operator, please. Is that so bad? Instead of writing vector.add AB. Oh gosh, nightmare. So Java treats you like an idiot in the attempts to eliminate stupid developers making stupid mistakes. And Rust kind of went down that same road with regards to memory management. Their take, however, instead of big garbage collector and we will never let you control where it's allocated and everything's on the heap, it basically goes down the road of, if I can't statically analyze everything you're going to do with this memory, I don't like it. So I always choose a small toy program, and it's Sudoku solver. So I have a 2D array of entries, and I needed to compare this element to things in the row, in the column, and in the block. So I wanted 2 references. I was going to iterate here, iterate over that little block there. Well, guess what? You can't have 2 references to the same block of memory entity. It won't let you because it cannot analyze it. It wants to statically analyze your memory and know when to release it statically at compile time, which is a great goal. But then they said, if we can't analyze it, you aren't allowed to do it. You're making my borrow checker sad because you have 2 references. It's like, but this is walking a 2D array. Like, this is kindergarten stuff in C. And I'm not allowed to by the compiler? Yeah, but I didn't want immutable. I wanted to be able to mutate depending on what I found in the rows and columns. Anyway, but the point was, this is just 2 pointers. Like, managing 2 pointers for even a moderately experienced C developer is trivial. So yeah, that made me mad. If they're like, you can't access memory that way because I don't understand it, well, that's you trying to babysit too much. I'm out. I don't want a babysitting language. And I have shot myself in the foot many times. Even on stream, I've debugged things that were just me being stupid, but if you learn how the underlying machine works, those errors go away, get down less and less. Like I said, there's a lot of things about Rust I really like, but at the point where they're like, you can't manage your own memory because we think you're stupid and we don't understand what you're trying to do. That was what made me mad. That pretty much set me off. So I finished that project, and then haven't touched it since. There are some cool things in Rust. I really do. I liked parts of it. But that's what turned me off. I'm not saying it's not worth the look. A lot of companies are moving to Rust because they've been told it's memory safe for exactly the reasons that it won't let me get two references to an array. So there you go. Mini rant. There was somebody, they gave this whole talk. They're like, here, how the borrow checker helped me, blah, blah, blah. And if you actually boil down what they did, what they basically did was they had a pre-allocated pool of similarly sized memory objects, and they were pulling from that so that they wouldn't hit the borrow checker. So in other words, what the borrow checker taught them was how to dodge the borrow checker. And they thought that that made them a better programmer. It's like, well, great. But that pattern has existed in programming forever, and you should, if you can, use a pre-allocated pool. That's just great performance-wise. So, yeah, fun times. I'm not saying don't learn Rust. Go for it. I like I said, I gave it a try. I liked a lot of it. And yeah, there's syntax and skill issues definitely. I didn't, which I've since forgotten. But anyway, yes. Now what was I doing? I need a file name. So we're going to compute a file name based on when you've typed your first character, which is this time info. We're storing the epoch. Therefore, I should be able to fprint a string 20-day char timestamp. Make it nice and big. It doesn't need to be this big, but you know, that's how we roll. We are going to, I think, is there a stir f time? It's Python. Does C not have it? Linux manual. Do they have examples? I like examples. I think stir f time is just what I want. Stir f time into timestamp. Size of argv1 temp is their structium. Okay, we might have to actually look this up. Stir f time. If not, we can. Oh, this. There we go. Copies into pointer the content of format max size. Okay, so not max size. That's the thing that's not usual. Format string and then time info. Then we need. I want 4-year. Which is probably modulus capital Y. Yes. So modulus capital Y. Year, month, capital M, usually for 2 digits. Just double checking. Oh, M, minute. Month as decimal. Modulus lowercase m. D, day. 0 padded, modulus D. What do we want? Hour in 24-hour format. Yes, please. I wanted things to sort alphabetically. That's why I'm a little bit particular about what order things go into. Minute, modulus capital M. Hour, minute, second. Modulus capital S. Is that it? Is that all I need? think so, which means then char temp equals global get app file name. I want timestamp and recording. Stir copy into, I forget what it's called, replay file name underscore replay file name temp and delete temp. This happens once during a game startup, so not a big deal if we allocate and deallocate memories instead of being a little smarter. So that's fine. Okay, so we're partly there. What's next? Let's see. We want to do a couple of things. Thinking, there's different options here. So one thing I do want is when we exit the game, it writes out any unwritten bytes from this buffer. So we need a function called write buffer to file or something. Or something like that. Void write replay buffer to file. Got all the information you need there. Right here. And it needs to do the following. Let's just do open. Oh, no. Yeah. There we go. Yes, there is an append. So we want to write append. File star out equals f open m underscore play in write append mode. If out equals null. We could get a real error message. We're going to just short circuit that for now. Log error could not write to file something or other. They're going to underscore replay file name. Otherwise, underscore replay buffer offset will be 0 at the end of this. F write is probably the right way to do this. F write to output file modulus. No, I'm going to say m underscore replay buffer and this many bytes. So, for example, at the end of the game, when you are done, this will be full. This buffer will be full. So we only need to write this many bytes. While we're adding things to the buffers, we're going to add a thing to check and see if are we full. If we are, right, call this. F close out. It's going to open the file repeatedly, but again, this depends on the number of user input actions, so I'm not as worried about it performance-wise. Oh, the bots showed up. Welcome, bots. They don't even stick around to watch and like boost my numbers. Isn't that sad? So rude. And I got the best viewers already. I don't know why they keep claiming to have better viewers than I've got. Very silly of them. I guess bots aren't that intelligent. Makes sense. So at the end of a game, we can do this, which we can do when? When can we do that? So surrender doesn't quit when the stopwatch gets stopped. You're not allowed to guess anymore. Okay, play state. That looks like the one we care about. So, oops. There we go. When we're in running state, when we lose, when we win, we actually go through a very similar process. Win or lose, that's kind of the two states. Let's break this out. Game scene, HPP. Is there like a good convenient place for next level, finish level, end game? We'll take a play mode, or not a play mode, a play state. Want to know what state to end in? If you just won, that's actually pointless. Repeat it again, modulus the guesses. Which I cannot remember. M underscore total guesses. There we go. Let's chart star text. Dot, dot, dot. That's probably the easiest way to do this. Finish. Oh. Win. We block the user from guessing, but we allow them to continue to deduce. We change the back button to, or the surrender button to a back button. End game. Show banner forever. We're gonna have to overload that one. Shoot. if state equals a context, play state win, we play this sound. Otherwise, we play the lose sound. Loser sound, that's what I called it. What else? You should probably be a little more explicit here. State is lose, otherwise. I don't know how to end a game in that state, in this state. There we go. Okay. So end game, everywhere where we say underscore stopwatch dot pause. Everywhere the state is win. End game. Congratulations. This is golf mode. All of that goes away. Stopwatch is paused. Game state will have to also be set in there as well. Okay, let's get that back. End game. If we're in golf mode, that's what we do. Let's see here. Actually simplifies things nicely. There. Actually need in some amount of time. We'll work out the formatting in a bit. So the stopwatch gets paused. Block the user. Yeah, so again, that simplifies nicely. Okay. End game win. End game. This one. Either way, the stopwatch gets paused, so that makes sense. We run out of guesses. If we're in sprint or golf mode, otherwise it's a win. Yeah, okay. So this is a lose. Lose. The answer was a thing. Selected word. Everything else goes away. Very nice. This one is a win. Okay, so in Marathon mode, you just go as many words as you can. There's no losing unless you hit surrender. If you hit surrender, it's a lose. So this is a win. Good run. I don't know what else feedback to give them. Like, congratulations, you went until you couldn't anymore. Nice bit of cleanup here, though. Simplifying code. So there's the win. Win, win, win. Lose. Oh, surrender. Yeah, okay, so this is just end game. A surrender is always a lose. That basically is it. Surrender is attached to a button, so I'm going to leave it where it is. So there's a lose, lose. There's only two ways to lose. You surrender or you run out of guesses. Does that make sense? Okay, so everything goes through end game now. So when we end game, write replay buffer to file. If image store replay buffer offset is greater than 0. So basically, don't actually open files unless you have something to write, in case anything gets weird. Write it, close it, point back to the beginning. I think that's it. So we should now see when we surrender or whatever, we should see those few states that we wrote, the 12 bytes. We should see 12 bytes written out somewhere. So let's build that, run it. What? I would never make errors. Let's see here. Replay magic number. It's not a static movement. Well, it should be. Yes, thank you. Show banner. Oh, yeah, we don't have that option. Show banner. BAR BA list. BA list. I think that's what it's called. Show banner. There we are. Right there. Okay. Oops. Let me think. Cheap viewers. All right, all right. The bots are listening to me, I guess. I don't want cheap viewers. I want the best viewers. I thought we talked about this already. Yeah, list args 2. Args. And bytes needed, args2 and args2. Args doesn't have to be ended by me. And everything else is the same. So this thing simplifies a lot. Args after format, show banner, vargs, duration, format, args, then clean up args. Okay. So show banner in end game here. Show banner V. So VA list args. XYZ, I want to show banner. Yeah, basically do this. Start after text. And show banner B, which is 0. The text and the arguments. And we're done. I think that's it. Okay. So end game is going to write our 12 bytes. In theory, unless I've messed something up. What's up? What the V overload is for? I have been a while since I've used variadic parameters. Sorry, not yeah. So, yes, here's what's going on. We go to show banner. We have a ... which means we have a variable number of arguments. We declare VA list, which says it's basically just an address saying after this parameter. So when we say VA start, it says this parameter here, format, find its address, figure out how long it is, and then args is the next address after that. Okay? Then you can pass args around. I can't pass ... but I can pass args. VAN says we're done with args, 0 it, nullify it, something. And these are just macros, start and end, and then VA copy. So then inside of something like fprintf, whenever it's doing the modulus S, modulus D thing, where it's looking up the format, or in my date case, where it's like year, month, it says, if I hit a modulus, look at the next character. If it's a Y, take the next parameter. I know what type that parameter has to be. That's why the modulus S is a string and modulus D is an integer. And return me that value. So let's see. I had somewhere the copy of a thing. Maybe we did it in... Anyway, let me just find a quick code snippet on C++. Let's see here. The sprintf might do it. Manuals. I have an example. No. And I gave away my C book to my brother-in-law. Anyways, basically, as you're writing through, it says, I know what modulus D is, it's 4 bytes. So I'm going to write out, I'm going to take that pointer, cast it to an integer, write that integer out. Then I'm going to advance the VA list, whatever that args, by the size of the expected parameter. So that's all this is. Now if I do this, I think it depends a little bit on the compiler whether it can figure out that this is an overload of this. So maybe we can try it. I don't know. But maybe it doesn't. I would like it to be a straight override if possible. Overload, rather. I'm not sure it will. Show banner V. Oh, it's long it. Oh, interesting. That's longer than I thought. I guess they fixed that before we ran out in, what was it, 2038 was the plan? Before we ran out of bits. Int 64. Pardon me. Ugh. Okay, so I lied. Not 12. We're getting 16 bits. 16 bytes. Just time t, huh? I guess it's just an integer, not a struct. Which is fine with me. I have a squeeze size of thing on this. It's an integer. You play buffer. I mean, that's a little bit silly. Replay buffer offset is an integer. So let's do a clean build, I guess. I'm just confused about something. Angered Gecko, why not variadic templates? No! 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 We are grug brain developers here, or at least I am. I'm not smart enough to handle that. Templates are basically used for containers, and that's all I will use them for. Okay, so for those who don't know, grug brain developer. Let's see. Yeah, right here. I'll put a link out. Classic. It's a great read. Basically, don't overcomplicate your code. Because yourself may be smart enough in the future to remember what you did that was very clever, but not always. And once you've done that, you also lock out a whole bunch of other people. Like, just keep it simple. Don't add things until you get there. So one of the things that's in his little manifesto there is every time I start doing weird templating things, you end up hating it. So basically, just use it for containers. I know they're super powerful. They do lots of things, but wow. Then copy. Invalid type for array subscript. This is not an int 8. And this is not a subscript. This is. Replay buffer. Maybe I'm having like. Oh. Yeah, here we go. Oh, I did not make this an array. That makes more sense. Actually, do it clean. Woo! That's just me being developer brain. Or streamer brain. So yeah, Greg Brain, developer. He's very amusing as well. High quality art. His grammar is a little bit lacking, but you know that fits. That fits with the kinds of people I hang out with. No, I've watched videos on variadic templates and all kinds of crazy things that they can do with templates these days. And at the time I get it, but then like it's gone from my brain. Because I don't use it. Because every time I think about using it, I go watch a video and I'm like, oh yeah, I could do it this way. And then I watch it again, I'm like, oh, there's no way I'll remember what this means in 2 weeks. Because I don't use it that often, so. F right. If I could read the documentation. F right. Pointer size count. Yeah. Pointer size of int 8t. C, this is one of the things I don't like about C. I don't think they're consistent in their parameter orderings. Like source, destination, then size of and count, right? Wouldn't that be easier? Everything else has been destination, source, and then whatever. Yeah, so pointers, destination, size, count, stream. I think that'll do it. Okay, now we're getting closer. F right. Oh, the string goes last? Is that? My brain refuses to accept that the file stream goes last. Unbelievable. So it's literally, unlike every other thing, it's now source, then size, then the file output. Unbelievable. I hate F right. It's the worst function signature. Oh, we'll get over it. Or something. Or just complain about it. That's what I usually do. Not that that helps much. Oh well. Okay. So in theory now we should get our 16 byte file written. We can, and then we surrender and quit. So in theory, C users the do app data roaming word sleuth. I don't see a file there. All right, I guess I have to print out some status as we go. Okay. Oh. Well, we do call this an end game. So Forget to flush. Well, it should flush when you close. I'm not maintaining an open file handle. I'm opening it as needed. We can flush it, that's fine. And it's not a bad thing to try. Flush? Oh, I'm not flushing anything anywhere. Out. Modulus D bytes. M underscore replay buffer offset. Alright, we should at least get something on the console. And with a flush, that might fix it. We run, we play. Surrender. Writing replay. Oh. Underscore replay buffer offset plus equals 4. Thank you. And 8. It's 0, so we never got to this line. Because yeah. But that does mean we can now do this. We can buy that by 1 line. If anybody cares. You know, I'm usually on board for some juvenile jokes, but I assumed you said it in good faith. It did run through my mind briefly to make jokes about training my younger children to flash and whatnot, but I didn't get there. I didn't deliver. Wow, interesting word already. Huh. Okay. D or O, therefore not S. Therefore J or K. If it's O, it's not that one. Let's go with black. Oh, interesting. So D is in. WX are out. B or Y. F or G. Anyway, surrender 16 bytes. Now it should be there. Sorry, easily distracted. Window. Data roaming. Where's Sleuth? Hey, there's a file there. Looking at it in hex mode. We can see our WSRP. Perfect. Some kind of timestamp, which is large, and then we've reserved 32 bits for our CRC or whatever we're doing here. Cool. So that's all working as expected. Nice. Since we don't need these notes anymore. Okay. Now, the old add to replay 1 byte. if this thing is greater than or equal to replay buffer size. Right, replay file, buffer to file. That's basically what we need here. Buffer size offset plus 4 is greater than. Write it out. And if it's 8. Okay. So now, even as we're streaming a game, even if it's a long-running game, we'll fill up this buffer, we'll write it out, and it resets everything back to 0. Start writing from the beginning of the buffer. It all should be good. All right. So I think we'll take that as our first win. Get file name. Record basic. Let's see, record some game status settings. What else? And then we're going to record user actions. Flushing to disk as needed. Okay. We're going to add more game status settings. There we go. We need that one, we need that one. Let's write a note. Game scene derives a file name when it starts the timer. Oh, let's see, stopwatch. I don't think stopwatch is guarded by game mode. I hope not. Finish level, we pause when we end the game. When we enter a letter, we do start the stopwatch if it's the first one. Then we update the time label, not all the time. That's fine. So we have basically start and pause. Okay, so that's good. Starts the timer upon user input. User typing. Game scene writes remainder of replay buffer when game ends. Part of this effort was refactoring end game to a single point. Game scene writes something. Let's see here. Magic number. Timestamp. Linux. Epic. And reserves 4 bytes for CRC or later. So we're not going to do anything with that CRC for now. That'll come later. Because eventually we will want some reasonable verification when we load a playback that it's in a good state. And I say reasonable. I don't know what that means. I mean, I know several things it could mean, but we'll check. This gum needs to be replaced, though. All right, that's magic number, timestamp, search 4 bytes received. Okay. Now, before we break things, playback recording has begun. Okay. Now we're going to record more game status settings. Go back to our own notes back here. Magic number, start timestamp. We are, yeah, it's not 32 bits, it's 64 bits. We need play mode, whether or not we're using animations, and the list of preset eject characters from the game context. Let's just move this up here so I can stop looking at those things while we just jump through this real quick. Play mode can be 1 byte. Use animations with 1 byte. So let's go to game scene. Now during startup, we get these 3 things already. Perfect. Oh, and we have to write those bytes. Okay. That's another overload function we can do. That's fine. Right. Replay buffer to file. Here. No. Add to replay. There we are. It's fine. I'll write those things out. Add to replay 1 byte play mode. That's basically it. Add to replay 1 byte. Whether or not we're using animations. Add to replay text. This one we have to write ourselves. Okay. Game scene. Construct star values. Length. YouTube buffer offset plus equals our length. I know things about this text, therefore I think we're okay to just do the following. Write our value, size of character, len plus 1, so we get that 0 byte as well, into, oh, no, we just do a mem copy, right? Mem copy, yes. Mem plus 1. I just want to add it here. Okay, add to replay text. All right, let's just try that out. Make sure it works. Play mode. Oh. As an int ht. Boolean, so it's a 0 or a 1. Yeah, okay. Let's just try to make it explicit. If it's used animation, it's 1, otherwise it's 0. These are reject characters. Run it. But animation. Okay. Whatever. Let's start the timer, otherwise we don't get our thing, and quit. So I should have written a new thing. Users to do data roaming word sleuth, and there is a new one. Yay, 14, 18. Stop recording. Exclude. Okay, WSRP. Then we have a timestamp that's 1, 2, 3, 4, 5, 6, 7, 8 bytes long. Then we reserve 4 bytes. Now we get 0 for play mode, which was marathon, which I believe is correct. Oh, for Pete's sake. Just game context. So marathon is 0. So that's a 0. Then there's 1 for use animations, which we agreed. And then we get B, F, G, J, K, Q, B, W, X, Y, Z, and a 0. So that's perfect. We wrote out everything we wanted there. Nice. So that's it. Verified. Good job, us. And that's basically everything we need to play back the game consistent with the way it was played the first time, as far as that goes. There's game scene now writes out in context settings. Use animations, reset reject characters, and play mode. That was an easy one. Playback writes out game context settings needed. I think that's really all it needed. Oh, let's not do that again. No. We copied this. We did not need to. Okay, done. Ingrid Gecko, gonna hop off. Thanks a bunch. Thanks for joining. Always happy to have you hanging out and having a chat. Have a wonderful evening, day, afternoon, whatever it is where you are. Okay, so we've saved that much, which I believe brings me to add event. Here. Here, it's actually not that hard to do the rest of this. Add to replay text. int t of our opcode. No, not text, 1 byte. Then add a and b. The rest of these I don't think have an argument, therefore we're done. I think that's basically it. I think that saves the whole playback. Where are we at? 2:30? Okay, so far. All right. Oh, except yeah, well that's not quite correct yet either. Don't. Oh, this is an interesting word as well. Look at that. M I and P B D. I think I'm trying to get the enough events B or Y that it flushes the file multiple times. Oh, there it is. So everything except BYWX. Link. So it's Y. Wimpy. There we go. All right. Okay. Surrender and quit. Let's see. Users, the dough, app data, roaming. Sleuth 2024 14 23. Interesting. How did those 4 bytes get in front of it? There must be something we write first. Opcode 0? 00112233. Opcode 9. Select random word. Oh, oddly enough, that is not what we want to write here. It is the one exception. Enter a letter. OF. Okay. Okay. Um, Play file. All right. Okay with that. What we need to do is put this up here in something like init game elements. Okay. We do not have raw time. Raw time is when we start the game, not when we start the keystrokes. I'm okay with that, I think. Okay. Therefore, you know what? Maybe just grab all of this. It all just goes into the game once. Just have everything ready to go from the start. Okay. Now, I did say that the one thing that is not correct, if opcode is not equal to opcode select random word. We do this. Select a random word. Now we write out different opcode. Here. Bit opcode select word. At 4 bytes. Word library. I don't remember what I put in here. Last seed. That was it. I don't want to actually store the number. I want to store the random number seed that we're using. Select the word based on this seed. So what happens is in word library, select random word, always reseeds. That way, each level is not dependent on the level or what animations you played. It's depends on what time you loaded the level. Then it selects the word. So when I select word, we're gonna actually have to change that a little bit. Or oh no, in this one we can do select seeded word. We just need to add a little function here. Not a big deal. That doesn't happen until playback anyways. So game scene. This is the one we're going. We say if we select a random word, we tell you select the specific word based on this seed. Now we're done. Okay. Everything else looks good. Let me see here. Actually, select word. Yeah, that's fine. Okay. Let me think. I'm going to figure out some of those excess files we're building up here. Okay. Those are gone. And we run it. Play. What the? What happened there? Um, full clean, I guess. Just to make sure. See, actually, shockingly, we're not far off of being done with. Oops, that one. Get those, get those. This thing. We need a timestamp and an opcode and the arguments. That's it. Timestamp, we're going to get from stopwatch. It is blowing up. Why would it do that? Backtrace. Free heap init game elements. 21. Result, they're allocating a new memory on the heap and returning it. Sure copy. Destination source. And I go to delete temp and it isn't a thing. Huh. Why not? Initialize game elements. TA 1A 19D0. I find that a little puzzling. Who is blowing up my heap? Your best off to bed. That's good. You should get some rest. Thanks for popping in. Always appreciate you in the chat. You have a wonderful evening as well. Huh. We're going to go put a breakpoint at 320. I guess. 320. Run. Okay, we're going to print temp. Looks fine. Print underscore replay file name, which is full of junk, which makes sense next. Print temp, print underscore replay file name. There's my 0 byte, so I did copy it. Next. Wow. Secure memory cache callback. Heap 321. Really, I cannot delete a string pointer to get back from global. Directory plus the log file plus 1 for null character plus 1 for the forward slash. Oh, okay. Wait. It's not Sterling app name. Sterling file name. Extension. Oops, let's see here. File len extension len. We've been lucky so far. Capture len. File len. Extension len. Plus 4. These are not comments. I don't know why these are comments. These are not comments. So the file length plus the extension length plus the after length plus we have a forward slash and a period. It's just 3. That's forward slash extension and an old character at the end. Yeah, that's just bad copy paste. Bad me, bad. Should look at the code I paste when I do that sort of thing. Now, am I so confident that we don't need to run the debugger? That is a good question. L is in, CE are out. IN has to be in, H out, M out, BD. Oh, that's an interesting word. Wing. Cool. Oh, there it died again. Shoot. It was mostly working. I wonder. Let's go ahead and add real quick. Okay. Oh, um, right now we're not really doing text things. Not a bunch of stuff, right? Play offset. Right. Replay. I'm wondering if I overran something I shouldn't have. I have options. Lots of things could go wrong here. None of them are that serious. We're gonna be just fine here. Okay. There we go, it died. Sterling. Sterling? Add event. Submit guess. Show banner. BS and printf. I don't recognize TOTUS. Okay. Two possibilities. One I don't like at all. The other one I also don't like at all. Show banner bars. Banner bars. And then the other one is at the end game. If it's picking the wrong overload, that could be part of the problem. Okay. E or D can contain at most one. Therefore, L is in. Therefore, okay. O or D, EMN. Let's see here. HMN, so M is out. Drain, that actually got rid of quite a bit there. That's very nice. E and O and H. F, G and O, P. Oh. Hobble. Not bad. So even playing one full level doesn't write out to the file. One level is about 200 and change. I'm a little disappointed that the overloads didn't pick up the right ones. That's just the way the cookie crumbles. Oh, there we go. It's B or Y. Study. Not bad. Yeah, so we're really not writing out the file very often at all. At all. Maybe I need to test by making the buffer much, much smaller. That is certainly an option. Oops, I just typed it again. That's awkward. Placed Rhino. Brown lines. M-A-T-R-N. R is out, D is out, O is in. BD. Odds. Jacks. Wax. Curious. I don't think it's Q, so Vomato, Vomat, Tovum, Zomat. Anyways, whatever. Let's just do this. Matzo. And quit. Now, there should be a file here for me. Users, Gitto, app, roaming, mode sleuth. Here we are, mana X. Hexagon mode, WS, RP, RP, then timestamp, then reserved bytes, then game mode, whether we're using animations, and then a bunch of letters, and the empty, the null character, and then everything from here on out is the play, is the gameplay. So that's working, I think. We will verify all of this shortly. However, it's 3 o'clock. I think it may be time for me to do a little snack run. Let's save what we've got so far. Let's write ourselves a note. Need a timestamp. That's blah blah blah. Okay. Game scene writes out each action, not timestamped. Yet. Let's just save our work. We don't want to screw it up. Okay. Scratch buffer. Snack run. Be back soon. Okay. And I'm back. Here we go. Okay. So one thing we need to do is in game scene. Mm, hmm. Oh, let me think. I have a stopwatch. The stopwatch. I think I need 2 stopwatches. Is that true? Is that true? Hmm. Think about that for a second. Although I'm thinking about playback right now, and I probably shouldn't. Um, I think we might as well just go to add event. I can think of 2 different things. All right. So one, the stopwatch. Let's go to scratch buffer so I can keep my thoughts straight. Stopwatch starts when user first types a letter, stops at end of level. And the reason we do this this stopwatch is for sprint mode. It's just replay stopwatch. Starts when level loads. Is that true? Is that true? If you win, it doesn't matter what deductions you do after that. That's not really part of the replay, unless I want it to be. So, for example, you have a loss and you get the replay, and you get all the way to the last 4 letters or something, and then you run out of guesses. You are allowed to continue to deduce until you figure out what the letters are, or find your mistake. which is that valuable in a replay? Watching you post facto find your error? Not sure how I feel about that. It does not fundamentally change the results of your replay. But you can show that you are able to deduce the correct letters. Let me think about that. Do I want to record non-gameplay interactions? That's kind of the crux of the matter here. Hmm. Yeah, I don't know how I feel about that. There's one thing that could happen. Let's just run it. I am allowed to change my deduction workspace and do stupid things before this timer is started. Which means if I write with timestamp all of those things, they'll all be at time 0. If I do that, and that, does it matter? Hmm. Hmm. Okay. So here's my current thinking. I could either write up a separate stopwatch or the things you do between levels or after the level considered instantaneous. In other words, while the stopwatch isn't running, all of those events will be entered at the same timestamp and therefore played back instantaneously. Right now it's running towards. Okay. So add event. Add to replay 4 bytes. M_stopwatch elapsed time, which is a float. Or is it a double? Stopwatch is a double. Buffer, memory copy, value, size of, buffer offset, moves. Oh, that's size of value. Double move before text. Text is one of those weird ones. What's everything else here? Just like that. Byte long matters. Add about event. Okay. So I think that is going to give us a much larger thing. However, let's get a smaller replay buffer. Let's go like 256. It should write out more often than it is for debugging purposes. In the end, I think 1 kilobyte of memory for this is just fine. I would like to write it, flush the file more often while I'm in while I'm debugging, just to exercise that system, or that segment of the system. Is my buffer full? Write it out before we keep going. Yeah, because so far 1 kilobyte's been enough to do 2 or 3 guesses. And if we use up a lot more memory, those double timestamps are kind of brutal on our usage. Okay. That's the way I want to approach this. All right, sprint mode, play. So I did write it out right there. Place Rhino, crowd, lines. Okay. Ultra Demon, IPS, AED, STMP, ENS, N, no D or M, or P and A and not T. 3D logs, jacks. Nope. Nope. F and G have the last 2 letters. Pages. Apes. Yes. Excellent. So this is written out a couple of times now. Write replay. So let's just do a quick search for that. One, 2, 3. We wrote out several times. So we can surrender and quit. Then we can load up our file. Oops. Half data roaming. Sleuth. That's not good. The letter K. Well, it's not even the letter K, it's just a byte. B. 0, B. Alright, replay buffer to file. Offset is greater than 0. Right append. Thought right append just puts me at the end of the file here. That's what you should do. Open file for output at the end of a file. Output operations always write data at the end of the file. Repositioning arguments are ignored. File is created if it doesn't exist. Oh, just A, not WA. Oh, that's the problem. So I'm going to delete this file. Oh, and this should be B. Okay. Append binary mode. Okay. That, in theory, should work much better for us. Helps if I think through the use case a little bit longer. Reset reject when the game, when the opcodes. It was good. Ultra demon lace rhino proud lines, therefore MAECH. Go away. Okay. DEON. Let's just throw drain. DIN. RIN. RIN. Therefore, D is out and O is in. Yes. Not those. Yes, please. And yes, please. And no. Prone. Not bad. Ooh, interesting word. BD. Logs. Jacks. Waxed. So WX has 1, therefore E has to be in, not B or Y. Actually, everything except WX. There we go. Now, Ultra Demon IP. No, not IP. What am I saying? W or I, P or I, W or X. Oh, I already knew P or I. That doesn't help. Like, there we go. No, not P, just I. Therefore, not D, but X. Mixer. There we go. My brain wasn't seeing it. Okay, now we surrender, we quit. And now we load a fairly significant sized file. No, it's significantly sized. It's still less than 2 kilobytes. We could save much smaller data where each timestamp is 32 bits if we wanted to, accurate to the millisecond. We could. Do we want to? it would literally almost have the size of this file. Where's the size? Where's my size? There's the size. I was not seeing it. 2002. Yeah, barely 2 kilobytes. We could chop that in half. Not by casting a double to a float. Now what would that cost me? 32 bits is 4.3 billion. If I go down to 22 bits, it'll give me 4 million seconds. 4 million seconds. It's a very long time. Let's see here. 22. Let's see here. Let's do a little quick math here. Okay, new plan. Not new plan, but let's talk about this. 64-bit double. Uses lots of space. Scales okay out to a large number. Level precision and Tissa. How many bits? Thank you, Wikipedia. It is 52 bits. 2 to the 52. Okay. Scientific. 2 to the 52 is a lot. But we can get 32 bits. 22 bits. So 2 to the 22 is 4.194 million. So if I do this seconds in days. So I could record a 48-day game before this breaks. And thereby have the memory I'm storing. And do so with millisecond precision. Is that worth it? Is that worth it? We could just store the doubles. So we could go for storing a 32-bit integer value, which stores a fixed precision out to 1 millisecond. Should let me store a game that's 48 days long before it fails. I like a nice compact binary file. I think we're going to do it. We can do it. This is easy. Okay. Insane. Add an event. That also means I don't have to store it a double elapsed equals this thing. Elapsed times equals 1024. And to replay. Oh. Elapsed is greater than, I did the math, this number. "48 days long. This replay is now garbage." I think 48 days is a reasonable time to finish a game, right? There we go. Most people are not going to notice millisecond errors. If we have a rounding error 1 millisecond or the other, 1, it comes out in the wash, plus or minus 1. We could. Hmm. Oh, and also if running. So we do that before we initialize, that's fine. It's add event. Add to replay. If the game is running, we do things. I think that's like a reasonable regard. 1 millisecond precision. You know what we could do? You can just make this actual milliseconds here. We don't have to use powers of 2 here. Elapsed time is there we go. Elapsed is greater than 4.194 million. And to replay 4 bytes integer version of that. Then we don't get opcodes. Okay. That's not bad. I think we're getting close. Somewhere, I'm going to need a way to examine this file. Where do I want to do that? Okay, so this is basically not plus or minus a millisecond, but plus a millisecond. We could do some rounding, but I don't think it matters. Okay. Okay. Now, all that being said, what kinds of things can we check? We can check number of events. We can check duration and end game time. In system time. Just trying to think of verifications we can do. So we're gonna do it now. Is kind of the time. Let me just think about that for a second. Play mode. Stores. Run result. Play mode. Dependent. At the end of the run, when you hit done, it better be close to this run result. Where the sprint and vsync matter. Do they matter? Could cause some drift in sprint mode results. Something to consider. Number of events and time. Basically, there's just more ways for me to verify my data in addition to the CRC or hash we're going to do. Number of events and end time. Reserved for end time. Reserved for number of events. No, we'll put the CRC first. Oh, 8 bytes. All right, so we go from raw time, or from start time epoch. Reserved. No, we put the hash after everything else, I think. Start and number of events and a hash. Those are my values to check. Tampering. So in endgame, we need to populate these 3 things. Okay. And image score replay event count. Play event count incremented. Then we need a hash. All right, our options are, we already have a Jenkins hash. Do we not? Oh, I don't have a Jenkins hash. Well, let's see here. We also don't have a CRC set up yet, so we should steal one. Luckily, I have some in code somewhere. A menu, show banner, two things. Where's the right replay buffer? Okay, so here. We need to write out a couple of things. M underscore replay event count is the thing we need. We need to compute a new epoch. So in init game elements, basically goes to this way we have a game duration in whole seconds. Then, so probably that thing, then this thing. And then we need a hash or a CRC. CRC. So we wrote a whole bunch of stuff to disk. Now we need to open it. Slightly differently. Instead of that, we're going to open it. We're not in append mode, just in write mode. F seek, which I now have to look up the order of arguments. It's going to move me forward to where we want to be. Stream offset origin. We're in binary mode. Seek set. All right, so that's the out. Offset will be, I forget, 12 maybe? Seek set. Then we're going to write some things and be done. Basically this thing. So we need to skip over 4 bytes for our magic number that we've already written. We're going to skip 8 bytes for the epoch we've already written, and we're going to write to our end time epoch, which happens here. FC12. We're gonna do that. We're gonna do that. Then F right. Raw time. Size of time t. We get one of those. We're gonna do size of raw time into output. That's the event count. Okay, there we go. CRC, except we're not going to do anything there. Actually, we can write something just to mess with it. Zero x 0, 1, 2, 3, 4, 5, 6, 7. Okay. Let's just see how that looks. So, right, F right, the address of that, the address of that. Okay. Okay, we've written some things out, some stuff has happened. Now we surrender, quit. Should have a file. Interesting. A lot of stuff got deleted or removed, or oh. If I open and seek, it should not erase everything before. Maybe I need a plus. Right. Plus B. Oops, that's not what I wanted to do. Close the window I wanted. Roaming. Let's delete that file. Yeah, okay. Is it R plus B? Right, try this again. I think it's R plus B is the mode I want here. Okay. Okay, things have done, things have happened. M-O-T, P, or R, or not U. R, not H, not P, E, logs, oh, there it is. F or G. Rinse. Nice, nice. Surrender. Quit. Hey, there's my WSR. Okay. WSRP. Starting timestamp. Ending timestamp. This 4 bytes should be the number of events we recorded. So, calculator, this is little endian, so, programming, site, yes, here, and hex 78 is 120 decimal events, which we would be able to verify if I was smart enough to print it out here. Replay event count. So that's my bad. We can't actually verify that we got that. Oh, and the CRC. We should be able to look at the CRC. Which was in reverse bytes 0, 1, 2, 3, 4, 5, 6, 7. Perfect. So I think that is all correct. I would just like to verify the event count is right. So this is actually pretty good. We'll grab a CRC, which is a bit of a cheat. Not a cheat, it just gives me free code that, because I wrote it before, I don't have to write it again, which artificially inflates my churn numbers for the week, but that's okay. Run it. Play. Okay. Now. Surrender and back. So we expect 69 events. WSRP timestamp. 45 in hex. Which is 69 in decimal. Perfect. So I think we're good there. All we need now is a what? I need CRC. So where did I stuff my CRC? I'm going to browse around for a second looking for my old CRC code. Options. C++ CRC32. Let me just paste that in the right directory, active projects, word Sleuth source. Boom, CRC32. So let's. There we go. I kind of lump it in with like random number generation. It's not quite. CRC32.0. Oops. Oops. That affects global. Global becomes CRC32. 1, 2, 3, 4. Done. So that will now build CRC32. Which is that. Our CRC32 table. Reset add a byte to 2 bytes and 4 bytes and byte array. Result byte count. Oh, we could do a byte count as well. Byte count and results. So that means I need 2 32-bit locations. And result. Yeah, it gets XORed one more time. Okay, so let's go to CRC32. Oh, I did good. 32. CRC32 underscore replay CRC. So if anybody has any questions about what CRCR is or what I would use it for or how it works, let me know. I'm happy to take a look at it and answer any questions. But basically it's a way to say, I went through all of these bytes and here's basically a hash number. So if at the end of loading the file, my hash agrees, then it's likely that what was written and what is read match. And therefore it sort of validates. Now, the CRC32 is not a great hash, so it's not cryptographically secure. If somebody really wanted to, they could fake the CRC and make it pass. But it would be much harder than if I don't have a CRC. If I do want cryptographically secure hashes, well, that means that I would have to store a private key within my software, which then somebody can reverse engineer. So it doesn't really have all that much safer. Well, we store a public key. And then I would use private key somewhere else to verify. I don't know. It's harder to do a cryptographically secure hash. This one's just enough to make sure that it's not easy or trivial to modify. So this has an empty constructor, which is good. Add values, that's fine. Add byte array, that's fine. The result of the byte count. So init game elements. Okay. Okay. Replay CRC dot result replay CRC dot okay. Yes. And now 22. Add 1 byte value. Add a 4 byte value. Add 8 byte value. Suppose we just cast that as a byte array. Actually, are we even using this anymore? Nope. Goodbye. But replay text. It's just a byte count. Okay, I don't think we need these anymore. Oh, yeah. We're gonna make this full of byte. Okay. Now we should get a real. Oops. That's fair. That should be const. Okay. Get 32t pointer of value. It will make a difference. Get 32t. What? Oh, you had 18 value. Jeez. Oof. Streamer brain here. So we should now have a few different ways to verify our file is probably okay. I lost the folder where I put the things and stuff. Nope, not that one. This one. App data roaming. Sleuth. Okay. What just happened? Okay. Let's do a full clean, I guess. Just to see how it's looking. Okay, actually, we have made pretty good time today. Okay, nothing broke there. Okay, things happened. That happens. Surrender and wait. Load this bad boy up. Pixel mode. WSRP. Replay. Timestamp. Timestamp. 39 is the action count in hex. 57 events. So, just to verify, decimal 57 is hex 39. Perfect. 1, 2, 3, 4. After which we have a hash and a byte count. That's a good thing we can double check too. So in hex 017C is 380 bytes, which we could have written out. We should have written out, but we didn't. So we probably should. After which, let's go look at the let's see. End game. Hash and count. We might as well log all that, right? Note. 32 modulus 08 x hash bytes. Right. Number 8 somewhere where I was undoing something. 120 undos. Okay. Okay, and then we surrender, quit, look at the file. Bonk. Next load. Timestamp, timestamp. 39 we already talked about is 40. 39. 90. 90 in decimal is hex 5A. Oh, this is the wrong one. There we go. So 5A, nice. Then we got a hash, which is B55E. So B5, 5E, 5E, 2, 5E, E2. Perfect. So that's the hash. And the byte count X is 233, which in decimal is 563. Perfect. Okay, so what's being written to the file is what I expect to be written to the file. So that's perfect. Nice. At this point, I think the right thing to do is to save our work, document what he's documenting, and delete that folder file. Then I want to read back a file and just make sure that what I've written makes sense. Let's go to journal. End time. Added timestamps. Integer number of seconds. Also have CRC32 end time in the file. We have 32. We need 32 bits reserved for game result, depending on mode. So let's maybe that. Let's just do it. All right. HPP. Not that one. Because I would like replay to contain the result of the run, like the record near the top. So I'll just finalize. This is a place where it needs to happen. Result. We could have start timestamp, magic number in the CRC. Oh, these are added. So the magic number, start epic, we dump 4 zeros into our CRC. That's for replay CRC. Here or reset? I can't remember. Reset. Replay CRC dot add 4-byte value. And 8-byte value. So that's like not having these zeros in here. You know, we don't need to do that. We can have the 4 zeros in there. It's actually a lot more than 4 zeros. It's fine. It's fine. Okay, so now reserved for run result and 1 byte. How much? This makes it a little bit faster and easier to look up these files and compare them. I'll have to read the first few bytes. Okay. So we're just reserving some space there. End game and then run result. So result. And then game context. State. Okay, state. Oh, I should get mode as well. Did I not save mode already? So these depend on what play mode we're in. We already saved play mode, right? Init game elements. Play mode. Yes, yes, we did. So 1 byte for win or loss, 1 byte for, and then 4 bytes for whatever this is. I think that's correct. Win or loss, and then the result. Uint here, we just go into T. State equals in context. State. It's an integer. Should be 2 or 3. That's a single byte. We should assert here at the top. State equals in context play state win or lose. Can't end the game in either any of those states. So let's get the state. Size of state. Okay. Switch underscore play mode. Marathon sprint workout. So we are definitely going to finish writing it out today, and we will verify that we can read it back in and verify the file. But what I don't think we'll be able to do is have playback done or high scores. That'll probably be tomorrow, getting the high scores done. I've still got an hour and a half, so we're not done yet. For marathon, result equals m underscore level -1. If we're in sprint mode, result equals m underscore total guesses. Ooh, that's not quite right. Oh. Yeah, it is. That's fine. Yeah. Sprint mode result equals. This is where we do another time thing, just like in add event. We basically do that. Okay. I'm gonna write whatever that is. So if that's the case, then we want to crc 30 m underscore replay crc dot add 4-byte value, 8-byte value, raw time, byte value m underscore replay event count. Or m underscore just state. And a 4-byte value for result. There we go. Let me just get the correct CRC. We have to read the entire file out of order. And with some dummy zeros. But honestly, that's not the worst thing that could happen. slightly harder for people to reverse engineer and try to cheat. Although, who would cheat at this game, right? It's too cool.
Why is he saying that?
Oh, let's see here. Here. Um, cheat. It's because we're declaring something in case, which case I could put it inside my context block, but it was not always necessary. Okay. What's more into the breach? STMP all the way. D is in, LA is in, note C, there is a B. B. Nope. Box. Jacks. Blacks. Failed. Blazed. Nope, not C. Leaved. Very nice. Okay. Five. Let me surrender, quit. We should have a file now. WSRP. And we get, oh gosh, I forget what all we've got here. Timestamp, timestamp. C5 is the event count. So in hex mode, C5 is 197 decimal. So there's the 197 decimal. We get I should write this down somewhere. Let's see. Let's go to Scratch. Word Sleuth replay. Let's see here. Oh, good heavens. Name, size. Magic number, size, 4 bytes. for Sleuth, replay. Followed by start time 8 bytes, limit epic, same for end time. Then I forgot. You can see. Number of events. 4 bytes. Integer count. Game state. 1 byte. Win or loss, which is 2 or 3. Result 4 bytes ends on load. CRC32 result 4 bytes integer CRC32 count 4 bytes integers we get play mode 1 byte use animations or byte the boolean play mode any of the valve play modes should work. Preset rejects C string then events. U C dash C dash. How do we know the order of everything? CRC processing is going to go magic number start time 4 4-byte zeros. No. 8 4 then 1 4 1. Oh geez. 1 4-byte 0. Then 4 4 4. 3 more. 3 8 4 1. And 3 4-byte zeros. Then play mode. Use animations. I think we write this down now while it's in our minds. We'll save us time later. Preset rejects events, then end time, which has some offset. End time. End time. End time starts at byte 12. At byte 12. Num events. Byte 20. Then our game state at byte 24. Result at byte 25. We do not process the CRC32 result or the byte count. Oh. File format. This is, there we go. File format and the CRC processing order. Events are special processing all around. It is the meat and potatoes of everything, but that's basically it. Am I missing anything? Is it clear what I'm doing? I want to just wander off into the sunset, leaving people confused. Just to do file format has been added in. See below more details. And the CRC processing is set. I think that's basically it. Oh, but did I actually verify my file? Where was I? Start time, end time. Okay. Number of events was the C5, which was 197 events. Let's go see. 197 events. Okay, after that, I expect the game state, which is a loss at 3. Yep. And I expect 4 bytes for the result. 2, 3, 4. So that is awkward. What mode was I in? I think I actually kind of want these 3 closer to the top. No, I want all this to be completely searchable, which means preset rejects has to be at the bottom. I'm not able to jump anywhere in this header before this. I think that is the correct answer. Um, So I have a result here. What game mode was I in? Two, three, four. I had a 1, 2, 3, 4-bit byte hash. 1, 2, 3, 4 byte count. Play mode 1. 1 is sprint, which means this is a time. Pretty sure game context. 1 is sprint, yes. So it's time based. However, that is a time in milliseconds. So if I punch this into a hex, I get 0.14F65. In decimal, yeah, it's 85-ish seconds, 86 seconds. Okay, all right. 3, 4, that's a hash. Count, I believe, is this from BA04. So let's check that in hex. 04BA 1210. 1210. And it's B537, or yeah, B537, A737, A737. Perfect. Okay, I think all of that is good. I think we're good. Phew. Now, replay offset. Okay. I think that's all good. And it's CRC32. Finished implementing most of replay save. See journal for details. Ornament and CRC. Okay. Oh, we saved. Oops. Let's see here. Did that. Okay. All in all, not a bad day's work, and I've still got good 40 minutes left, 45 minutes left. Sweet. Man. I feel like I've been going pretty good today. Let's see. The old to-do list. We need to save and load replay. Mostly need to load the replay and verify that we're reading it correctly. So question the first. Do I want to break replay out into its own class? I kind of do. We're out. Replay from game scene. So we're gonna want some. It is somewhat separate from the rest of it, so yes. Okay. I'm gonna pause for a restroom break. Then we'll get right into that part. We'll move it out of game scene into its own little class. Game scene will then use that class instead of continuing all that code. Then we'll write code inside that class to load a game scene, a replay, and verify that it's correct as best we can. So, if we get that far, that would be a good day's for 1 more hour. I'll be right back. Okay. All right. So we're gonna move replay into its own thing. I am generally okay with this. Basically, all of that. ERC. Probably need the log. Count buffer offset. Actually, just call it offset. Let's just simplify that. Okay. Oh, this needs the time. Yeah. Just want to see standard 8. Okay. We'll need C string. Initialize our replay object. Literally just looks up timestamp information. Which of this do I want inside the replay thing? Almost none of it. Okay, initialize it, then we write a bunch of stuff. all of which I'm fine with. I think replay can have an access to game state. That should be fine. In context. We also want C string, I believe. Those are mem copies. A whole bunch of the word replays around here. Bit Rioter. Howdy, howdy. Welcome back. How's it going? How was your weekend? Just regular you? Yeah, doing pretty good, pretty good. Can't complain. Things are going well. So I mean, ish. It's could be better, but could be worse. I've had worse, much worse. So I'll take it. I went shooting. No, I have not gone shooting yet. I'm not going camping next weekend, so maybe I'll bring along some firearms. But I didn't go shooting this weekend. I did some wood burning. I think what else I did. Oh, yep, had my daughter's birthday. That was always fun. Always fun. At this point, I feel like I should have just done like a search and replace, but almost there. So we're working on saving out a replay so we can rewatch our games if we want. Check a number. This is what I should have done. It's a little faster. Okay. Dun 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 dun. Oh, right. Dun 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 dun. Okay, that wasn't too bad. Should call that right. Okay, big file. So down near game scene, I guess. Play.o. Yeah, she's trying to do. Oh, I never shot a gun. I'm so eager to learn. Probably visit some range in a few months. Never even held a gun. Oh my goodness. You're missing out, man. It's it is a tool to be respected, but it is also a lot of fun. It's really only 3 or 4 rules you have to memorize for proper firearm handling. And it basically goes like this. Rule 0. This is one of the few truths in life where the lie is more useful than the truth. And that is, you always consider your gun to be loaded. You never, ever wave it around or point it, or even if you have opened the chamber, ejected your magazine, and you put your thumb in the chamber, right? You still consider it loaded. The truth is not as helpful as the lie. Rule number 2, you don't point the gun at anything you do not want to destroy. For obvious reasons. There's a corollary to this one, and that is, know what's behind your target. So if you go to a gun range, they have a big, thick wall. Usually it's like, they make out of lots of sorts of things. Or maybe outdoors, it's there's like a big rock cliff wall or a big dirt hill behind where you're shooting at. Always know what's behind your target. And then rule number 3, don't put your finger on the trigger until you are ready to pull it. You keep your finger up on the side of the firearm, out of the trigger guard. You follow those 3 rules, remembering the caveats. And then rule 4 is you always follow the instructions of the range master immediately. So if you go to a shooting range, someone is in charge. And as long as you listen to them, and you do those other 3 things, you'll be fine. And then, yeah, it's a lot of fun. Shooting stuff is great fun. Highly recommended. A bullet shot by a 7-year-old is as effective as the one shot by a trained soldier. Yes, that's the whole point of a firearm, is a force equalizer. Yes. Yes, it's an equalizer. You don't have to be good with a firearm to be every bit as deadly. The whole point of them is, if somebody big comes at you, it doesn't matter how big you are, you can defend yourself. Now, you also have local laws, so you need to know what those are. So if I were to shoot someone in self-defense, I know that there are certain criteria I have to meet before I can pull that trigger, or even draw the gun. But, so know your local laws, memorize those 4 rules for proper gun handling, and your chances of actually having a good time and not hurting anybody are pretty good. Yep. Great force equalizers. Okay. I only own a 2 or 3, depending on how you want to count them. That's not true. Somewhere between 2 and 5, depending on how you count them. I am in Canada, so I can't do any of those federally. Yeah, but I mean, if I remember right, you said you were in Montreal. That's not that far from the United States. You can hop over the border, do a little weekend shooting. As long as you like showered well and did your laundry before you came back, I don't think that the sniffers will pick up anything at the airport, right? Oh, Toronto. Oh, even closer. Yeah, easy. Yeah, you could find yourself a gun range in pretty short order. Okay, okay. Yeah. Cool. Go do it. It's a fun weekend. Okay, so let me think. The compilation's finished. So let's see if it's still writing out my files. Play. I have a brother. He's quite into his guns. He builds his own, and he's wicked into it. Which state are you from? I assume South? No, I'm from Idaho. Way over in the west. Right next to Oregon, Washington, Utah, in that corner. Okay, so we quit. We do get our new file, and WSRP looks okay to start with. Only visited the US once, San Francisco. Well, you could have picked a better place to visit. San Francisco is a bit of a dump now. It used to be a cool, unique, interesting city to visit, but now, unless you're really into the kinds of things San Francisco is into right now, it's really not a great place to visit. I did some work for a robotics company out of Kitchener. So I'd fly into Toronto and then drive to Kitchener. So I haven't spent time in Toronto, but I've visited it twice, driven through it a couple times. Otherwise, I've never actually been out of the United States myself. Just the one visit. Okay. So that refactor was good. Making sure I'm not like, oh, I'm not that. Okay, I did not do it right. There we go. It didn't compile. It. Oh, yeah. Let's also change the names. Add 1 byte. Add 4 bytes. 8 bytes. Text. To replay. That doesn't fix that other issue, but that's fine. Yeah, I'm trying to think. Correct, it is in replay. Raw time was not declared. You are correct. Okay, so I want raw time stored in my replay real quick. And the time t m_start time. underscore start time 0, I guess. Init. M underscore start time. M underscore start time. Okay, then I need a way to get it. Time t start time. So after we initialize, play turn underscore start time, which now is being seen. Replay dot start. Replay, the magic number can be public. Being seen. Okay, so I'm giving you that right made public. Replay. Okay, let's see how much further we get. Oh, okay. Maybe we change this just a little bit. Let's put right down in private. Init and finalize. When we finalize, we do the right. We get a file. Okay. Replay dot finalize. It's not equal to null. Then we do these things, although oh, finalize seek. Not sure how I feel about some of this. Although I think this is close to what I want, but we're gonna do let me finalize int c. Game scene. This is the important thing. Oh, let's see here. Okay. stdio. I was just going to return a boolean. File star underscore final file is null. Assume failure unless we prove otherwise, then the result will be true and return the result. So, in scene, if finalize here, what we're gonna do, we're gonna make a couple of small changes to replay.cpp. Only add a byte. If the game is running, we do things one way. Otherwise, m underscore final file is equal to null. Then we do things differently, which includes basically that. value. Bytes basically does the same thing. 8 bytes does the same thing. Text is slightly more complicated, but I'm not actually using that else. Replay.add text not implemented for finalization. Right. In theory, we can just do add. So your underscore replay. Add one. Okay, so that should sort of replay that add 8 bytes. Replay that add bytes. Replay replay event count. Result. Add 4 bytes. Result. CRC, we can do underscore replay add 4 bytes of hash. And byte count. Count first. And I think hash first. 132T hash equals. This is basically where we stop. Spark Blues. Am I using Linux? No, I'm on Windows, but I loaded it up with MinW, Cygwin, MSys2 type of environment. So, developing the game for Windows, since that's where most of the viewers are, or not viewers, most of the games are in Steam. But since I did everything in a Linux-like environment, it shouldn't be too hard for me to port it if I need to like SteamOS or Mac. Might not be as straightforward, but maybe I could still swing it. It's a decent amount of Linuxy stuff underneath the hood. So yeah, welcome to the chat. If you have any questions, let me know. I'm happy to give you a brief overview of the project or whatever, and otherwise, I just kind of talk stream of consciousness while I work until somebody asks a question. Um, any timestamp at 8 bytes. Do that. Computer result. Okay, this is not it. It's not game scene replay. Complete. File. Gold. Add close. File. I see what I did. Okay. So in theory, finalize. Where's my finalize? Assert equals win or false. Assert seek is greater than or equal to 0. Assert underscore final file not equal to null. Should be able to call complete otherwise. Okay. And we're coming along in the compile stage here. Replay, event count. Oh. Okay. Okay. Replay event count. PT CRC result const CRC byte count const. CRC dot result. And byte count. Okay. Yeah, so we need to bring the replay event count back. Replay event count. Let's move that up. Right there. Replay event. Basically that. All right. Event opcode. Right. I guess we just need to move this up a bit. Okay. 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 Um. I tend to agree. Replay needs global. That's fine. That's kind of the whole point of global. That's my warning to start wrapping up. So lose, win and lose, not win and loss. Okay. Yes, out was not declared. Underscore file. Oh. Hmm. Okay, looks like we need to build out of this one. Phew. Finally. Okay, now it just crashes, so we have restructured things. Let's do clean. Just make sure it's a good clean build. This works. We'll probably call it there for the day. Tomorrow we will read it back in and write like a validate function. Great. Once we have that done, we can work on one of two things. We can either work on our high scores, keeping track of those and deleting unused replays, that kind of thing, or at least renaming them. Or maybe we don't rename them. And then I don't know, there's a number of ways we could do this, but okay, nothing crashed yet, so let's IES, no M, ED, nope, nope, Jacks, nope. Interesting. So no F, no G, no E, no Y, no J, no K. But there's a W or an X. Let's see here. Y's would fit. Nice, nice. Okay, it wrote something out, so that's good. I can see it in my file explorer. Ultra demon laced rhino proud lions. Interesting. And then we will surrender and quit and quit. This file should be full of data. SRP. So a word sleuth replay. Timestamp, timestamp. Some number, play mode, or game status, game mode, etc., etc. Okay. I mean, it looks reasonable to me. So I'm going to call that a win right there. We will document our progress. Replay has been separated out from game scene. To do, I'm going to load the playback. Validate, get key info, like win loss, result code. And then playback is, so like I said, tomorrow we're going to do this. This one's going to get all done tomorrow. Then the question is, do we want to playback replays, or do we want to start treating with our local high scores? A couple of bugs, we can deal with those. Yeah, I think by the end of the week we'll have these all done. And then we're mostly down to art, music, sound, some extra animations. Really, honestly, we're in pretty good shape. This is good. after only 10 weeks. Well, considering where I started and where we ended up at, we're in pretty good shape. This is good. Good progress. Good progress. Okay. Let's status get add everything. Make dash factor replay out of games. It's all cleaned. And yeah, pretty good work today. Pretty good day's work. All right, well, thanks for joining. Thanks for the chats. Always appreciate your company. Hopefully you found it interesting or educational or something. And yeah, we'll catch you tomorrow, where we will load in replays and decide which of the two routes we want to go. Yeah. So thanks. Have a wonderful evening, and I'll talk to you tomorrow. Bye-bye.